Hello and welcome back to another video. In this problem, we're asked to graph the given functions on a common screen and ask how are these graphs related. So I think the easiest way to do this is to take a graphing calculator and graph all of these functions. If you graph them by hand, which you can do, we know from our work in this section that they're going to have the general shape of this, right? Where we have the point 0, 1, and very low in the negative numbers, approaching 0, and goes off to infinity in the positive direction. However, they all have the same general shape, and for the values which we've selected here, they are all very similar. They're not too spread apart if we were going to try and graph them by hand, which is why we're not going to do that. What I have here is a graphing calculator, right? I've pulled up on Desmos our functions. And what we can do here is get rid of this light so you can see the screen properly. We can see the small differences between these functions. So all of these functions, we can note, go through the point 0, 1, which we know because any value which we are taking to the 0th power, which is x to the x being 0 is the exponent, so 2 to the 0, e to the 0, 5 to the 0, 20 to the 0, they all equal 1, so they all go through the point 0, 1. What's interesting here is what happens after that point. So in red here, we have 2 to the x. We can see that that increases slower than the others. Then we have e to the x, and 5 to the x, and 20 to the x. And what we can see is that the higher the base, the quicker that it increases, right? That makes sense. 20 to the 10, for example, wherever that is, far off the graph, is a lot bigger than 2 to the 10. And in the opposite way, when we are less than 0, the 20 to the x, this purple line here, is decreasing the slowest. And the 2 to the x is decreasing, the 20 to the x is decreasing the fastest, the 2 to the x is decreasing the slowest. And that also makes sense. If we have 20 to the negative 2, that's 1 over 20 to the 2. 1 over 20 to the 2, which is right here, is a lot smaller than 1 over 2 to the 2, which we have right here is negative 1/4. It's positive 1/4. So we can see here, all of these points go through the same point, but they have different trajectories in both directions based off of their bases. However, we know that it doesn't actually matter in the end because at their actual end behavior, off to infinity and off to 0, they all go to the same place. So hopefully through this Desmos demonstration, we can get a better grasp of how these functions actually relate to each other, better than a hand-drawn graph would have worked.